So we did last time we did electrophilic addition, जिसमें था कि we did जिसमें था कि we did all of this. We talked about alkenes having a high charge density, which is why they're going to polarize the bromine molecules, and the electrophile will be very strongly attracted to it. The positive bromine is going to be very strongly attracted to it, and so the reaction will happen very vigorously. So most of the conditions were kind of very mild. Okay, when you have an alkene with bromination happens, you had very mild conditions, and it was a very vigorous reaction. Alkenes with water, alkenes with hydrogenation, all of these reactions. So they were very strong electrophilic addition reactions. We talked about the Markovnikov's rule, major and minor product. I told you, the reason H likes to bond with the carbon atom that's already bonded to more hydrogen atom is that secondary or a tertiary carbocation or a 2-degree or 3-degree carbocation is more stable. So that mechanism is preferred where 2-degree or 3-degree carbocations are formed. And that will happen only if the H decides to bond with the carbon that's already bonded to more hydrogen atoms. अच्छा, next one. हाँ.
सर वो जो बॉन्डिंग होगी लाइक वो अगेंस्ट द रूल होगी वो माइनर होगा ना?
हाँ, वो माइनर होगा. ठीक है. अच्छा, अब ये कि जो नेक्स्ट चीज है, that is that we are going to talk about electrophilic. अच्छा, we're going to talk about electrophilic substitution in benzene. So electrophilic substitution in benzene. Okay, so we're moving away from alkenes or electrophilic substitution in benzene. What is it? Okay, first thing. What is going to happen is I'm going to write the overall reaction. That what is going to happen is that you're going to have a benzene. So example, I have. So I have this. So there's this benzene with the ring in the middle. And there are going to be a couple of electrophilic substitution reactions of benzene. The reaction is simply that you reacted with Br2 and you would need a catalyst for this reaction. So the catalyst is AlCl3 or not AlCl3, sorry, AlBr3, or you can also have FeBr3 as a catalyst. So you need a catalyst for this reaction. And as a result, the product that you're gonna get is this thing. You're going to have a bromobenzene molecule as the product. Okay, so there's a benzene, and a Br is going to get added to this benzene. And the other molecule that's produced is an HBr. That's an HBr molecule. So that is the overall reaction. You can also have another electrophilic substitution with chlorine, which is exactly the same. So all you have to do is you just have to change the Br. So all you have to do is you have to change the Br with Cl. तो यहाँ पे ना you just replace it, and the catalyst also, instead of AlBr3 and FeBr3, it's actually AlCl3 and FeCl3. Any one of the two. And you're going to get you're going to get chlorobenzene plus HCl is going to be produced. So that's these are two reactions, and there's another one which is known as nitration of benzene, which is kind of the same. कि nitration में ये होता है कि I'm just writing down the overall reaction. I explain the reactions. So you'll have a benzene, and you'll add concentrated nitric acid and concentrated sulfuric acid. Plus concentrated sulfuric acid is added. That sulfuric acid is basically behaving as a catalyst. So it's like an acid catalyst. And the conditions for this reaction are that the temperature is going to be 55 degrees centigrade. And the product you're going to get in this reaction, वो ये है कि यहाँ पे ना there's going to be an NO2 that's going to get attached. हाँ जी.
सर ये जो ऊपर वाले रिएक्शंस है ये स्टैंडर्ड कंडीशंस में होंगे या उनके लिए स्पेसिफिक लाइक टेम्परेचर और प्रेशर?
नहीं, पहले वालों में तो कोई कंडीशंस वगैरह स्पेसिफिक नहीं चाहिए, ठीक है. अच्छा, सो ये सब रिएक्शंस है और इनको बारी बारी डिस्कस करते हैं, ठीक है. दिस इज लाइक आई मीन जस्ट लाइक एल्कीन्स. तो अगर आपने if you want to add a Br next to a benzene, you want to add a Cl next to a benzene, or you want to add NO2 next to a benzene. So these are the reactions and these are the conditions for the reaction. Okay, this is known as electrophilic substitution of benzene. And the conditions are given, all the conditions. You have to remember the conditions. Now, the reasoning behind and the mechanism of these reactions, okay? Why do these reactions happen? So we're going to discuss the mechanism in detail. Both mechanisms, electrophilic substitution mechanisms, are exactly the same. So electrophilic substitution mechanism.
सर
हाँ.
सर वो एल्कीन के केस में इलेक्ट्रोफिलिक एडिशन था ना, सब्स्टिट्यूशन नहीं था.
हाँ, वो एडिशन था. दिस इज सब्स्टिट्यूशन, ठीक है. अच्छा, अब इसमें ये कि starting with electrophilic substitution mechanism, the first one I'm going to discuss is bromination and chlorination are kind of exactly the same. So we're going to discuss about bromination, or you can just change the Br to Cl. It's going to be chlorination. So that's the first one. Now, what happens in bromination is that you have a benzene. Now, what does a benzene actually look like? Benzene is this thing. Here, वापस जाएगा. This was the molecule benzene. So let me, and it had an electron cloud. Let me copy everything. Take this back. उसको मैं यहाँ पे ये सारे आप कर देते हैं. अच्छा ये सारा that's a benzene. अच्छा mechanism discuss करना है ठीक है electrophilic substitution. Why would it first thing why would it react with the question is why would it react with bromine in the first place? इसको दोबारा एक सेकंड में बस ठीक है अच्छा so the question is why you had a delocalized electron cloud an electron rich center. What would happen is that the bromine molecule is going to come close to it, and since the bromine molecule is kind of non-polar, it's got a couple of shared electrons. So the bromine molecule will slightly get polarized. The electron density in the benzene over here, it's going to repel the electrons in bromine. All the electrons in bromine are going to will kind of get knocked to the right side, or they will be repelled. So some polarization is going to happen. The bromine will become slight negative and the other bromine will become slight positive. And the slight positive bromine is going to be attracted to these electrons even more strongly. So there's going to be an even stronger attraction for electrons. और इसको एक सेकंड कर लेंगे अच्छा there's going to be a very strong reaction for or an attraction for मैंने इसको शेड कर ले So I've got this delocalized electron. The bromine molecule is going to be attracted to it. Now that delocalized electron is overlapping with everyone else, but the bromine molecule is polarized, and the positive bromine will get attracted to it. Now the issue is the polarization is not going to be very strong. ठीक है जिस तरह alkenes में था ना the polarization over here is alkenes के अंदर we discussed कि when you had alkenes हाँ जी तो उसके अंदर हमने
सो उधर से इशू आ गया था कनेक्शन का जरा फिर से एक्सप्लेन कर सकते हैं ये वाला
नहीं मैं खाली वो कह रहा हूँ कि alkenes के अंदर ना when bromine would come close to the pi electron cloud, the pi electron cloud had very high charge density, so the polarization was very very strong, which basically meant that the electrons will get repelled very very strongly, and there would be a very strong positive bromine and a very strong slight negative bromine. So polarization strong थी. यहाँ पे issue ये है कि when it comes to benzene, the same thing happens. You've got a pi electron cloud, and the bromine molecules कहाँ गए? अच्छा, and the bromine molecules come close to it, but the polarization is kind of weak. There's going to be weak polarization, not that strong, और क्योंकि वो weak होगी, पहले उसकी reason लिख लेते हैं. There's going to be weak polarization. Benzene electron cloud has low charge density and does not repel the bonded electrons very strongly. Achha, it has low charge density and does not repel the bonded electrons very strongly.
सर बॉन्डेड इलेक्ट्रॉन ब्रोमीन वाले
हाँ bromine वाले तो थोड़ी बहुत repulsion होगी but not a very strong repulsion. Is that clear? So
yes sir
Achha, which is why there's not going to be any attraction. Because the positive bromine is not going to be it's not going to be a very strong positive bromine. So opposite repulsion is not going to be very strong. So the negative bromine is not getting repelled enough because not enough negative charge. And the positive bromine is also not getting attracted to the negative charge very strongly because there's not enough negative charge. The charge density is very low. So there's not going to be a reaction. So इसलिए ना alkenes के case में you would have a reaction at room temperature, but in benzene the reaction will not happen. Instead, what you need is you need a catalyst. You need to increase the polarization of, because the polarization is so weak. You need to somehow increase the polarization of, I mean this weak polarization, it somehow has to be increased. So the way that is increased is कि on the other end you add a catalyst. तो यहाँ पे ना you will add an FeBr3 catalyst or an AlBr3 catalyst. So what that iron catalyst will do is that the iron catalyst, because of its larger number of protons, will start attracting electrons from the other side. And that will increase the polarization. Because on one side, the bromine was actually pushing electrons away in the bond over here. And from the other side, there's iron catalyst that is actually trying to pull the electrons towards itself. The iron 3+, it's strongly attracting the electrons from the other side. So in this way, the polarization increases. And और यहाँ पे ना, the positive charge is going to be now significantly larger. Similarly, the negative charge is also going to be significantly larger as well. So you're going to have very strong. So you're going to have very strong polarization. So ये clear है सारों को कि why do we need iron in this case? Is this clear?
Yes,
सर
sir.
हाँ जी.
सर आयरन क्या अट्रैक्ट करेगा बीआर को अपनी तरफ?
हाँ, नेगेटिव बीआर को. नेगेटिव बीआर को और प्लस उसके इलेक्ट्रॉन्स को भी, so that this bond breaks. क्योंकि you were not getting a reaction. You were not getting a reaction because the polarization was weak. उसके इलेक्ट्रॉन्स को अट्रैक्ट करेगा ना अपनी तरफ. So ये इधर से इलेक्ट्रॉन्स को पुश कर रहा होगा. On the other side, the iron is trying to attract the electrons. So that is your first step. ठीक है. Second step is कि once this happens, तो ये मैं second step draw कर रहा हूँ. ठीक है. अच्छा, once this happens, I'll do all the working on this. ये green वाला मिटा देते हैं. अच्छा, now this bond over here is going to break. The electrons are going to be attracted to FeBr on the other side. So all these electrons and this Br will take the electrons in the double bond. And this Br-1 is going to get attracted to the electrons. And all its electrons will be attracted and they will end up forming a dative bond with Fe. ठीक है. Bromine's electrons, the bromine, instead of bonding with the other bromine, is now actually, it has ended up bonding with this other FeBr3 catalyst. And the catalyst will become negatively charged because the Br-1 has come towards it. So what will happen to the other one? The other one will become, because it has lost electrons, the other Br will actually become a fully positive ion, a Br+1 ion. Because somebody took its electrons. I mean, this Br over here took its electrons. So this is what's going on. This Br positive is now going to be because it's now a full positive ion, so it's going to be very strongly attracted to the benzene electron cloud. So what it will do is that it will try and bond with the benzene electron cloud. So it's going to steal some of the electrons. So some of the electrons over here, specifically ये जो electrons carbon के ऊपर थे, these ones. These are the electrons that are going to be attracted and they will go towards this Br+1. The Br+1 is going to strongly attract those electrons. So instead of carbon having a delocalized electron cloud, this particular carbon does not have a delocalized electron cloud anymore. और इसका +1 charge खत्म हो गया. The +1 charge would now actually be on this entire benzene ring. Why would it be on the entire benzene ring? Because somebody took an electron from this electron cloud over here. So the electron cloud becomes electron deficient. So ये आपका second step है. This is what happens, what goes on in the second step. तो मतलब ये पहला दूसरा step similar ही है. First step it was bromine. It had to be polarized, and the way you're going to polarize it, you're going to add a catalyst, and the catalyst will try to pull electrons from the other side, and the bromine molecule will get polarized. The negative bromine will go and join with the iron, forming a data bond in the process. The positive bromine has no option but to get attracted to the electron cloud, and it will steal electrons from the electron cloud. It will bond with one of the carbon atoms, and your electron cloud is now partially complete because one of the carbon atom, the electron cloud, is missing because the bromine took its electrons. ये भी clear है सारा?
सर
हाँ.
सर ये FeBr के ऊपर -1 चार्ज जो लगाई है -2 नहीं होना चाहिए, हो सकता है कि क्योंकि दो टाइप्स ऑफ आयरन होते हैं ना.
नहीं, ये वाला स्पेसिफिकली Fe3+ है. ठीक है.
सर FeBr को पुल करेगा.
किसको?
FeBr को पुल करेगा.
हाँ, हमने ट्रांजिशन मेटल जब पढ़ा था ना चैप्टर, तो उसमें ये था कि आयरन जो होता है ना, it has a lot of protons, so it has this attraction for electrons. Transition metals का ये था ना कि they can lose electrons, they can also gain electrons back. Like if you have Fe3+, that Fe3+ can change into Fe, and the same Fe can turn into Fe3+ as well. So Fe जो है ना, उसने इसके इलेक्ट्रॉन को मतलब स्टार्ट से देखो ना, Fe was the one that attracted the electrons and attracted the negative bromine. The positive bromine instead was going and getting attracted to the electron cloud over here. Clear है बात?
Yes.
अच्छा, अब ये कि last part, मेरे को last step. अच्छा, starting with this one. I mean, the electron cloud is electron deficient because somebody took its electron. So somebody has to give the electron back. वो जो somebody है ना, that's H. जो H है ना, it has a very strong tendency to actually lose electrons and form H+1 ions. So what will now happen is कि H जो है ना, अगर मैं ऊपर वाले में ड्रॉ करूं, H जो है ना, वो अपने electrons वापस कर देगा. ठीक है? So this H will return the electrons. And that same H+1 will try to grab hold of these electrons over here. So this is what's going on. The H will leave its electrons with carbon. So carbon's pi bond will be complete again. What you'll have is electrons on this carbon atom again. And those electrons are going to overlap. So those electrons are going to overlap, and they would eventually bond with and form the pi electron cloud back again. So ये बीच में ना जो positive charge है, that is no longer needed because it's gone now. And that substitution happening because the Br was the one that took electrons, and now the same Br is back. Br was the one that took electrons. H is the one that actually ends up giving its electrons back. So where did that H go? The H started attracting the Br in this molecule, and it will end up forming. I mean, this Br will be removed. And an HBr molecule is going to be produced again. So that's your complete mechanism for this reaction. All electrophilic substitution reactions are kind of like this. First thing, bromine got polarized, but not very strongly, which is why you needed catalyst to begin with. You needed a catalyst to start the reaction, so that one of them will I mean, one of them is pushing the electrons, the other one is pulling the electrons. So the Br negative is going to get attracted to Fe, while the positive bromine is going to be very strongly attracted to the benzene electron cloud. Next step is the electron cloud will become partial or incomplete, and when that happens, the H is the one that ends up losing electrons, because H has it's a very electropositive element. It's always trying to lose electrons, so it ends up losing electrons, and as a result, the electron cloud becomes complete again. You again have benzene. The H is lost. That H goes to Br and bonds with it. It ends up forming HBr, and you get an FeBr3 catalyst. तो ये आपका पूरा mechanism है. Mechanism clear है सारों को?
Yes, sir.
ठीक है. बाकी को clear है? Rizwan, Alisha, Seeb is
Yes, sir.
Yes, sir.
अच्छा, खैर, obviously paper के अंदर you're not supposed to draw this three-dimensional stuff. In paper, what you have to do is you just have to. So I'll draw the mechanism in the one that you have to actually draw. ये तो वैसे ही 3-dimension में show किया हुआ है. So this is your mechanism for exams. उसमें क्या है कि you just take benzene as a skeletal formula. So what you're going to have is so here's the mechanism. The first thing is a bromine molecule will come in. The benzene electrons are going to be attracted to bromine. Its electrons are going to get repelled. And somebody from the other side, which can be FeBr3, LBr3. So that likes to gain electrons. So bromine's electrons are getting gained by iron on the other side. So that's your first step. And you're going to draw every single thing correctly. Curly arrows, etc. Everything has to be shown. This bromine is slight positive, and this bromine is slight negative. Anyways, the next step is you're going to have the same. You're going to have the same benzene. As the next step is you're going to have the same benzene, and और अब उस benzene पे ना what is going to happen is on this benzene, on one of the carbon atoms, there's going to be an H attached, and it's also going to have a Br attached. Or ऊपर से ना, the electron cloud is going to be partial now. So the electron cloud is not going to be present on all the atoms. So it's going to be partial, and it's going to have a positive one charge. And the next step is that you'll have FeBr4 minus 1. And then your H is the one that gives its electrons back. And then as a result, your benzene's electron cloud is going to be complete again. तो ये जो है ना, ये आपका complete हो जाएगा, and when that happens, कितना है उसका?
सर
हाँ जी.
सर जो आधा सर्कल है सर वो पार्शियल उसको दिखा रहा है.
हाँ, वो ये शो कर रहा है ना, ये जो, हाँ, इसी को ना कि बीच में Br came along and took electrons from the carbon atom. ठीक है? I mean, this is what happened, right? So the electron cloud is partial now.
Yeah.
Or if somebody gave the electrons back, H in this case. तो ये आपका ना total mechanism है इसके अंदर ना, that's all, everything is self-explanatory, ठीक है? So that's your total mechanism for this particular reaction. Clear mechanism paper में क्या draw करना है? Is that clear?
Sir,
Yes.
we can also have AlCl3 instead of
You can.
Br2, right?
Yes, you can have AlCl3 as well. And you can have Cl2 as well instead of Br2. Okay, so everything will be exactly, I mean, the mechanism will be exactly the same. So I mean, this is the mechanism that you have to draw. ठीक है, ये बस आपका ना वो curly.
सर इसके अंदर वो एल्यूमिनियम वाली कैटलिस्ट यूज कर सकते हैं?
हाँ, वही पूछा था उसने. अच्छा, ये आपका ना positive one. अच्छा, ये आपका ना सारा आ गया, ठीक है. Now the other thing is कि there's so this is one. I mean, they're going to ask you this. I mean, this is like the major mechanism that you have to learn, and they'll keep asking questions about it. Now the next one is nitration of benzene as well. It's a similar mechanism. Everything is exactly the same. बस उसमें ये कि अगर मैं इसी को कॉपी करूँ ना और उसको मैं चेंज कर दूं नाइट्रेशन, ठीक है. लेट मी जस्ट कॉपी एवरीथिंग. अच्छा, नाइट्रेशन का जो मैकेनिज्म है ना, उसके अंदर there's one major difference, and that is कि वहां पे ना you would add a catalyst and there was going to be another reaction initially. So what would happen is that you'll use concentrated nitric acid and concentrated sulfuric acid. So these two will react together, and the reaction that's going to happen is it's going to be nitric acid plus 2H2SO4, I think, and they would react together. And when they reacted, they would form H3O plus 1 and 2HSO4 minus 1 plus NO2 plus 1 is going to be produced as well. That's nitronium. And that is going to be our electrophile. It's going to be attracted to positive, negative things. So ये reaction, this has to be remembered for nitration. If I just copy the reaction as well for nitration, it was simply this. You just take benzene, you add concentrated nitric acid, sulfuric acid, and the reaction is going to happen. अच्छा, ये सारा मैकेनिज्म था. उसका पहली इंपॉर्टेंट चीज है वो ये कि concentrated nitric acid react. When they react, they produce an NO2 plus 1. So they end up producing an NO2 plus 1 electrophile, जो कि ये है. And once that electrophile gets produced, what will happen is pretty much the same thing. It's going to be exactly the same thing. I said now catalyst वाला जो काम है ना वो पहले ही हो गया, so you don't so I'll just modify the mechanism first, and because the Na2 has already been produced. So what happens in this case is the catalyst, since it has been produced in a separate step, instead you're going to have just NO2 plus 1. So you're going to have NO2 plus 1, and that NO2 plus 1 वो यहाँ पे जाके ना बेंजीन के साथ ये चीज नहीं है, ठीक है? This is not. The NO2 plus 1 is going to borrow electrons from the benzene, and it will become NO2. Okay, next step in, there's going to be an HSO4 minus 1 ion that's going to come in. And that HSO4 minus 1 is going to grab one of the hydrogens, and the electron cloud will become complete again. And the catalyst gets regenerated. So you'll have NO2 over here, plus H2SO4 gets to be formed again. So it's the same reaction. It's the only difference is now you've got an NO2 plus 1 electrophile which gets attracted to benzene. वहां से वो electron borrow करता है, जुड़ जाता है, and the H then leaves, leaving its electrons, it goes and joins the H4 minus 1, and your HSO4 H2SO4 catalyst gets regenerated. यहाँ पे लिख भी देता हूँ कि the catalyst is getting regenerated. और फिर NO2 आके जुड़ जाता है. That's it. ठीक है, that's the mechanism. इसको बस मैं complete इसको लिख लूँ कि electrophilic substitution कि you'll be asked to draw this one. So the negative version of this is kind of the same, except वो दो तीन चीजें हम बीच में ऐड कर देंगे. So I'll just copy this. So nitration के अंदर you don't have all of this. All you have is NO2 plus 1. And the same thing, no FeBr4 minus 1. You'll have an NO2. And instead what happens is you get HSO4 minus 1. You get money from somewhere, and that it's HSO4 minus 1. उसके इलेक्ट्रॉन्स जो है ना वो इसकी तरफ जाते हैं, ठीक है, और H पे जाके उसका जुड़ जाता है, और इस NO2 को हटा देते हैं, सॉरी Br को हटा देते हैं, NO2, and it becomes H2SO4. तो ये आपका पूरा mechanism है, ठीक है? That's what you're supposed to draw. तो आपके पास you have two mechanisms, one electrophilic substitution, that's it, ठीक है? All questions would be revolving around electrophilic substitution. उनको आपने ना याद करना है, ठीक है? This is the mechanism. One of them, मैं इसको जल्दी से कर लूं, one of them is with NO2 plus 1. NO2 joins with the benzene electron cloud. The H then leaves. Okay, it goes and joins with HSO4 minus 1. So you've got a displacement, you've got a substitution that's happening. पिछला वाला भी exactly same था कि bromination, you had bromine. The bromine will get polarized. You'll add a catalyst. If Br3, that catalyst is going to attract electrons from the other side. The positive bromine is going to go and join with the benzene electron cloud. The electron cloud will become partial. H then gives its electrons back and goes and bonds with the Br minus 1 in FeBr4. तो यहाँ पे एक चीज HBr बनेगा और प्लस FeBr3 कैटलिस्ट, और यहाँ पे दोबारा रिफॉर्म हो जाएगा. तो FeBr3 gets reformed. जो ये क्लियर है सारा, ये वाले मैकेनिज्म, इज दिस क्लियर?
सर
हाँ।
सर उसके अंदर वो नाइट्रिक एसिड तो वापस से रिफॉर्म नहीं होगा ना?
नहीं, नाइट्रिक एसिड तो रिफॉर्म दोबारा नहीं होगा, क्योंकि वो तो नाइट्रिक एसिड तो रीएजेंट था ना, वो तो NO2 बन गया ना। HSO4 जो है वो दोबारा रिफॉर्म हो जाता है, वो कैटलिस्ट था। मतलब व्हाट वर द कंडीशंस फॉर दिस रिएक्शन? द कंडीशंस फॉर दिस रिएक्शन वर कि यू ऐड concentrated नाइट्रिक एसिड, वो आपका दैट वाज योर रीएजेंट, वो रिएक्ट कर रहा था। HSO4 was the catalyst and temperature was 55. तो इसमें पहले स्टेप में होता है कि the electrophile is created when the concentrated nitric acid and sulfuric acid they react. तो जब वो रिएक्ट करते हैं ना, the catalyst gets, sorry catalyst कह रहा हूँ, ये electrophile gets created और वो फिर आगे जाके ना रिएक्ट करता है। चलो क्लियर है ये?
यस सर।
तो ठीक है, हमने मैकेनिज्म्स कर लिए इलेक्ट्रोफिलिक सब्स्टिट्यूशन, ठीक है। अभी थोड़ा सा इलेक्ट्रोफिलिक सब्स्टिट्यूशन और थोड़ा पढ़ना है, सो वील डू दैट इन द नेक्स्ट क्लास देन, ठीक है। कोई और क्वेश्चन नहीं है किसी का इस पे? अलीशा, सराइजिस? हाँ
सर लास्ट क्वेश्चन सर, उसके अंदर ये फिनॉल्स और ये आएंगे इसके अंदर?
हाँ, तो इसी में आएंगे ना।
ओके सर।
चले, ओके, अल्लाह हाफिज़।